Welcome back. So today we would be covering, talking about algorithms and the problem they solve. Right. Before we get started, right, this session has specifically been designed keeping a manager perspective in mind. And as managers, right, we are expected to answer question like, how can we reduce a non-performing asset ratio for a financial firm, or should we launch a new category in an FMCG segment, or how can we improve employee productivity, right? So when it comes to solving those kind of problems, algorithms and data does help you to effectively solve the problem. But when it comes to the number of algorithms that are present to solve your problem, right, it can get really frustrating when you try to focus on the how, that how does these algorithm work, right? But you can perform much better, right? Or you can be quick in your learning when you first focus on what does the algorithm solve, what kind of problem does the algorithm solve. Now let's look at three basic problems that can be solved using machine learning algorithms: classification, clustering, and regression. So first we will take the problem of classification. As the name suggests, classification problem is about classifying the input into different classes. Like we see in the image, this image can be put into class A as bell peppers. This image can be put into class B as tomatoes, and this image can be put into class C as oranges. But on the other hand, if there is a different kind of a use case, we can also put this into a class A, but that class A may signify as exotic vegetables, class B as regular vegetables, and class C as citrus fruits, depending upon the use case. Here is a live example that how a camera using artificial neural network is able to identify, is able to detect, right, a pear with 98.2% confidence, and it is able to detect an apple with 99.2% confidence level, right? Now let's look at the algorithms which help us solve a classification problem. So here is a list of popular classification algorithms like logistic regression, k nearest neighbor, decision tree, artificial neural net, random forest, MCM, and stochastic gradient. All these algorithms help to classify inputs into multiple classes out here, something similar to what we have seen before, into class A, class B, and maybe class C. Now, if we look at what other problems does classification solve, right? So we have already spoken about image classification through how we are able to recognize different kind of fruits. Another popular classification example is sentiment analysis, right? Whether a person is smiling or whether a person is sad, right? So there are two classes. Class A, person is sad, and class B, a person is happy, right? And we are able to identify using facial detection. Then another example of classification is fraud detection. Whether the fraud has happened class A and whether the fraud hasn't happened class B. Alright. So we are able to identify using these algorithms, we are also able to develop fraud detection systems. And one of the most popular use cases of classification is also trying to when you put your mobile phone camera to an image, it is able to identify similar products, it is able to identify matching products, and probably also develop a styling meter. All right, so this is a typical classification problem where we are trying to identify the class of this apparel and then match it up with the similar products and then match it up with the matching products. All right. So let's talk about clustering now. So clustering is the task of grouping of set of objects in such a way that objects in the same group are more similar to each other than in the other group. So if we were to apply a clustering algorithm to a customer database like this one, then it may cluster this set by income, or they may cluster this set by age also. Like in this case, it has clustered this whole set on the basis of the place where they're living, either people living in metro cities, tier 1 cities, and rural areas, right? So, the algorithms which are powering these, clustering problems, the solution to these clustering problems, some of them are k-means, k-medians, expectation maximization, and hierarchical clustering, right? And this is how, this is an output of a clustering algorithm where they have put it into multiple clusters. And I've also put another, like on, customer segments, you can see when in an actual system, when you throw your data to a clustering algorithm, it may be able to cluster your algorithm with centroids as these red marks. These red marks are the centroid of your clusters. All right. And what are the examples, right? More examples of clustering, or what are the real world examples where clustering is majorly used, right? So that would be your recommender systems. For we also use it for target marketing and customer segmentation. So customer segmentation also feeds into targeted marketing. And one of the famous use cases of clustering is your recommendations made by Amazon.com. Calculation of your credit score on the basis of your income level, age, education qualification, and more is a classic regression problem where the output is a continuous value, either a 500 or a 400 or a 900, right? And that identifies your credit score, which helps financial institutions identify how much credit that can I give to the person. Now let's look at some of the algorithms which are powering the solution to regression problems. So these are ordinary least square regression, linear regression, logistic regression, stepwise regression, and MRs and Lewis, right? And one of the key aspects of all these regression algorithm is they try to find the line of best fit. Okay. So moving on to the examples of regression is that of forecasting, where we are forecasting the sales of a certain brand for an FMCG company, or we are making prediction, and it also helps in process automation. So here is a summary of all the algorithms we have discussed till now, categorized by problem types. Okay. But there is usually a lot of confusion between clustering algorithms and classification algorithms. So we will add another layer of categorization where all the clustering algorithms are majorly unsupervised based learning algorithms, whereas classification algorithms are supervised learning algorithms. So when I say supervised learning, that means you have input data and the corresponding output data to be fed to the system. And when I say unsupervised learning, it is only that we have the input data and no corresponding output data. All right. So going back to where I started, where I said that managers should not focus on how these algorithms work, but they should focus on what these algorithms will deliver or what kind of problems it solve. But still, if you still feel that you want to understand algorithms in depth, right? I would say that you take up these algorithms and read up about them on the internet. That would be linear regression, logistic regression, k-means, knn, random forest, svm, and ann. And this is a good starting point for you to explore your algorithm journey. All right, thank you.